So now next technique in the integration is about partial fraction method. So we'll see how to solve the questions with the help of partial fraction method. So here if you have function of this type, for example, I want to integrate this 1 upon integral of 1 upon, let's write x plus 1 into x plus 2, product of linear factors in the denominator. Now one way is you can just open this and you can convert into quadratic and you can integrate. Now another way is what we do, if you have just 1 upon x plus 1 or 1 upon x plus 2, you can integrate it very easily. So we here express this product of linear factors as a sum or the difference. So we'll do like this, here 1 upon x plus 1, here 1 upon x plus 2, and I'll put minus sign here. You see, you just verify. If you take LCM of this expression, you will get exactly this. Do cross multiplication, you will get this. So what we did here, instead of product, you have expressed as a difference. And now this can be integrated very easily. What's this? This being a linear function, you can imagine this as x. So log of mod of x plus 1. Linear function, imagine this as x. So log of mod of x plus 2 plus c. And therefore finally you can write log of mod of x plus 1 upon x plus 2, property of log function. Subtraction become division, plus c. This is your answer. Product of linear factors can be expressed as a difference here. This from this to this procedure is known as a partial fraction method. So like if I have product of 3 linear factors, for example, x plus 1, x plus 2 and x plus 3. Now this you cannot do directly. By if opening the bracket you will get the cubic. There you were getting quadratic. So this cannot be expressed by cubic polynomial expression, and further it cannot be integrated. So what we do is here we express this some constant upon x plus 1, some another constant here x plus 2. We'll find some one more constant upon x plus 3. This may be plus or minus, this may be plus or minus here. And after doing this, now this can be integrated very easily. This is log of mod of x plus 2, log of mod of x plus 2, log of mod of x plus 3. So from this to this is known as partial fraction method. Every product of linear factors or quadratic can be expressed as a sum or the difference. From this to this is known as partial fraction method, PF method, partial fraction method for integration, right? Now you may have, I'll give you some standard functions. Suppose function may be in this form. I'll write here function like this, one linear factor here, px plus q upon here let me write ax plus b cx plus d. Linear factor upon product of the linear factors. So what we'll do, we find constant a upon one linear factor plus another constant b upon linear factor. This to this, from this expression to this expression, we'll find ab in such a way that if you simplify these, you will get exactly this. And this is known as partial fraction method. One more you may have like this, product of for example here I have a linear function px plus q upon, I may have px ax plus b cx plus d and ef plus g. Then I can express here as one constant upon ax plus b plus another constant upon cx plus d plus third constant upon ef plus g. So here product you have expressed as a sum or the difference, and ABC will find in such a way that if I simplify this, if I take LCM here, I'll get exactly this. Fine. So you may have, remember, 2 linear factors or 3 linear factors. That's not important in the denominator. Okay. Sometimes you may have like this repeated factor. One more, let's do that. One more question here. Third one. Suppose here I have linear factor px plus q upon, I may have ax plus b the whole square. Repeated factor. So in that case we write one constant upon ax plus b plus another constant upon ax plus b the whole square. We'll take all powers, not here 2 and not here 2, remember. We'll consider all powers starting from 1. Suppose here if I have like this px plus q upon, let me write like this, ax plus b the whole cube. Now this is called partial fraction method with repeated factor. So a upon ax plus b upon ax plus b the whole square plus c upon, one more time, ax plus b the whole cube, this way. This is called partial fraction method with repeated factor. If I write this as the 4th point, partial fraction method with repeated factor. If you cube, then all powers, 1 power, 2nd power and 3rd power. We find a, b, c in such a way that if you simplify these, you will get exactly this, remember. So from product to plus or minus, this is what the partial fraction method. These are some standard functions you may come across in the next exercise. So I'm showing in general, remember. Now when you use the partial fraction method, the power of numerator function, here 1, here total power is 2. If you expand this, this become x square. So power of numerator function should be always less than the denominator of expression. Then and then the partial fraction method should be used, remember. One more, you may have sometimes like this, 5th one. Suppose here I have linear function ax plus b. Here one linear function cx plus d and one quadratic px square plus qx plus r. So here what we do, we express in this form one constant for this, because derivative of any linear function is constant. So a upon cx plus d plus, now this is quadratic. What's the derivative of any quadratic? You know it is a linear function. So we'll write here bx plus c, bx plus c, because a already used here, bx plus c upon px square plus qx plus r. So when you have denominator function as a quadratic, then you will set here linear. When you have linear, you will set the quadratic here, a constant here, I'm sorry. When you have linear function, you will set as a constant. When you have quadratic, you will set as a linear function. We will find a, b and c. These are the unknowns in such a way that if I simplify this, you will get exactly this. So this is same as this, remember. And now this can be integrated very easily, because constant upon linear can be integrated. And this is linear upon quadratic, that can be integrated very easily. Fine. So these are some 4 or 5 standard function. One is linear into quadratic, constant upon the linear function, linear upon quadratic. Here linear function, constant upon one linear, another constant upon linear function. We'll find a and b. You will realize in sums once we start the exercises. Here 3 linear factors, so 3 unknowns. Here this is partial fraction method with repeated factor. So you are going to take all powers, 1, 2. Here your cube. So 1, 2 and 3, not just cube, remember, right? So we have such functions in the next exercise. First we'll convert from this to this. This is called partial fraction method. Integration will be just one line, remember. We'll convert from this form to this form, because product cannot be integrated, you know, very easily. Here repeated factor, so we convert in this form. Here repeated factor, we convert in this form. If you have linear into quadratic, then first constant upon linear and then linear upon quadratic. And as I told you, partial fraction method is applicable when you have such expression. Then the degree of numerator function, that is this function, should be less than degree, that is the power of denominator function. If you have like this, for example, x cube plus 1 upon, for example, let me write x square plus 1. Now this cannot be directly integrated using partial fraction method. Cannot be integrated directly, because here you see power is 3, here power is 2. If I have this like this, x plus 1 upon, if I write let me write x minus 1 into, let's write 2x plus 3. Can we use here partial fraction method? The answer is yes. Using partial fraction method, this can be integrated, because here power is 1, here total power is 1 and 1. So if I expand, it becomes 2. So this is a quadratic, hence power is 2, here power is 1. So degree or the power of numerator should be less than the degree of the denominator function. Okay, so that you have to keep in your mind. If you have such function, you cannot use directly partial fraction method. Remember, you need to do something else. We'll see if you have such questions. Okay, so now we go to exercise 7.5. Question number 1. Integrate x upon x plus 2. You can see here your product of two linear vectors, and this is one linear function having power 1 and here power 2. So partial fraction method can be used, remember. So this is equals to, what's the method? Method is this: one constant upon x plus 1 plus another constant upon x plus 2. Why we wrote the constant? Because these are the linear functions. Okay. Now our main task is to find the values of a and b, remember, in such a way that if you simplify these, you will get the above expression. So what we do, we here compare the numerators. What is numerator here? X. What is numerator here? Take the cross multiplication. A into x plus 2 plus b into x plus 1. Denominators are same, you can see. If I do cross multiplication, what is denominator? X plus 1 into x plus 2. What is denominator? X plus 1 into x plus 2. What I did, I have just compared the numerators of the previous step and this step. What I did, I have just compared the numerators. Now I'll take, you can choose any value of variable x. I'll choose the value of variable x in such a way that 1 should be 0. Suppose for what value of this should be 0, minus 1. I'll put here. So in the above equation, so it implies if x equals to minus 1, it implies this is minus 1, your a into this is 1 plus 0. So you will get a equals to minus 1. It is not necessary that always you should select minus 1. But if you select minus 1 here, one of them becomes 0. That's the logic, remember. Next value, how do we select the next value of x? You must have realized, take minus 2. If I take minus 2 here, left hand side is minus 2. Here a into 0 plus, if I put minus 2 here, b into minus 1. So you will get the value of b here. What is the value of b? Minus 1 will get cancel, b is 2. So now the above integral, finally you have this. What is a? Minus 1 upon x plus 1 plus what is b? 2 upon x plus 2. So this is not integration, remember. This is called partial fraction method. What you did, product of two linear vectors, you see this product cannot be integrated. So from product 2 you could express in this form. Now this can be integrated very easily. You just take the cross multiplication. If I do in rough, if I take cross multiplication, numerator will be x only. You see minus x minus 2, here 2x plus 2. You can see that this will goes away, 2x minus x, so x. Right, this is just for your information that this is just same as this, remember. Okay, now integration, last line. What is integration? Minus 1 being constant as it is. What's the integral of x plus 1? That is log of mod of x plus 1 plus 2 being constant as it is. What is integral of this? Log of mod of x plus 2, linear function, remember, plus c. So this is your answer. Now here further, if you want to simplify this, you can write here minus log of x plus 1 as it is. You know that this is a property of the log function. This 2 you can take into the power. So this will be plus log of x plus 2 the whole square plus c. And now this is addition and subtraction, so it becomes division. So this is log of x plus 2 the whole square upon x plus 1 plus c. This is your answer if you want. You can keep in this form, but further if you want to rewrite, you can write like this. Okay, now let's go to next question. So question number 2 is 1 upon x square minus 9. If you remember, this is our known formula, 1 upon x square minus 3 square dx. Now this is which formula? 1 upon x square minus a squared. If you remember, it is log of 1 upon 2a, if you recall, log of mod of two factors x minus a upon x plus a plus c. So here answer to this is 1 upon 2 into 3 log of mod of one factor x minus 3, the other factor x plus 3 plus c. So you will get the 1 upon 6 log of mod of x minus 3 upon x plus 3 plus c. This is the answer. Let's go to third question. Question number 3 here. Integral of 3x minus 1 upon x minus 1 into x minus 2 into x minus 3 the whole dx. Product of here how many linear factors? 3 linear factors, 1, 2 and 3. So we'll do by partial fraction method here. One constant, ignore numerator time being, one constant upon x minus 1, another constant upon x minus 2 plus third constant upon x minus 3. So we have this here. A upon x minus 1, B upon x minus 2, C upon x minus 3, where A, B, C are unknowns which we'll find. How we'll find? By comparing numerators. What is the numerator here? 3x plus 1, 3x minus 1, sorry, that is equals to, what is numerator here? If you take cross multiplication, both of this multiplied with this, so A into x minus 2 into x minus 3 plus B into this into this, that is x minus 1 into x minus 3 plus C into product of these two factors, x minus 1 into x minus 2. What I did, I have just compared the numerators. Cross multiplication, A into product of these two, B into product of these two, C into product of these two. Numerator is this. After taking LCM, you know that this both the denominators will be equal. Just I have compared numerators, remember. Okay, now we select the values of here x. How do I select the value of x? You know, right? First I'll put x equals to what I should take as x. I'll take if x equals to, what should be x here? In such a way that this becomes 0, that is 1. Put in this entire expression. So if I put 1 here, 3 minus 1, 2. Why we have chosen this 2? Because here you will realize the two terms will be 0. So this is minus 1, this is minus 2. This, if I put 1 here, this is 0. If I put 1 here, this is 0. So both will be 0. So you will get a from this. 2 will get cancelled, minus minus will be plus, so a is 1. This 2 will get cancelled, minus minus will be plus. Okay. Next, what should be next value of x in such a way that this becomes 0? So x should be 2 here. I'll put 2 here. 2 into 3, 6. Minus 1, 5. If you put 2 here, this is 0. I'll put here 2. So 2 minus 1, 1. Here 2 minus 3 minus 1. If I put here 2, this is 0. So I'll get the value of b. What is b from this? B would be minus 5. Just check this. And the last one, that is, if x equals to, next, I choose in such a way that this becomes 0. So 3. X equals to 3. So 3 3s are 9 minus 1, which is 8. If I put 3 here, this is 0. If I put 3 here, this is also 0. If I put 3 here, 3 minus 1, that is 2. And 3 minus 2, which is 1. So from this, C is 8 by 2. 8 by 2, which is 4. So you got A, B, C. A, B and C. And now we put these three unknowns in this expression. Here we are going to put. So this integral 1 upon x minus 1 minus 5 upon x minus 2 and 4 upon x minus 3. Just placing the values of a, b and c. So what you did, this is called partial fraction method. The product of linear factors you could express as a plus or minus. This is not integration. Now we have integration, remember. What is the integral of this? This being linear, imagine this as x. What's integral of 1 upon x? Log of mod of x minus 1. Minus 5 as it is. What is this? Log of mod of x minus 2. This is linear. Plus 4 as it is. What is this? Log of mod of x minus 3. Plus c. This is your answer. Log of mod of x minus 1 minus 5 into log of mod of x minus 2 plus 4 log of mod of x minus 3 plus c. This is the required integral. Question number 5, we have 2x upon x square plus 3x plus 2. Now this can be done by earlier technique. This is linear upon quadratic, you know. This is linear upon quadratic. So you can do as we have discussed earlier. But I want to do by partial fraction method. So how I'll do this? I'll factorize this. You know here factors are x plus 2 into x plus 1. Quadratic I'll factorize. Now as I did, one constant upon x plus 2 plus another constant upon x plus 1. Fine. Now we'll find a and b. How do we find a and b? First choose x equals to what? Minus 2. So no, I'm sorry. We need to compare the numerators here. So what is the numerator there? 2x. What is numerator here? A into x plus 1 plus b into here x plus 2. We have compared the numerators. Your numerator is 2x. After the cross multiplication you will get this. Now first we choose x equals to minus 2. So this becomes 0 and you get one of the value. Then you put x equals to here what? Minus 1. So we'll get the other values. Place there and integrate it. Come to question number 6 here. In the 6th question you have 1 minus x squared upon x into 1 minus 2x. Now you see here in this question Now here, if you observe, this is a quadratic expression, 1 minus x square upon, this is x minus 2x squared. So this is also quadratic. Now in such questions, you cannot use directly partial fraction method. You know that degree of numerator should be less than the degree of denominator. Then and then, degree means power. Here powers are equal. So directly partial fraction method should not be used, remember. So what we do in such questions, if you have quadratic upon quadratic or linear upon linear, I'll set this expression over there. I'll set denominator expression over numerator. So I want to set this expression over there. I need minus 2x squared. So first multiplying dividing by 2. So I'm getting 2 minus 2x square upon x minus 2x square. Now what I'll do, I need x there. So I'll just add and subtract x. So I'll write 2 plus x minus 2x square. What I did, I've added x. So I'll write minus x upon x minus 2x squared the whole dx. This is very commonly used method in integration if you have quadratic upon quadratic. What I'm trying to set this expression over here. I need first minus 2x squared. So first multiply and dividing by 2 throughout the expression. Fine. Then I need plus x. So I have added x and I have subtracted x. Now what I'll do individual division considering this as 1. So this upon this gives us 1. So this is equals to here half as it is outside. This upon this gives us 1. You are left with 2 minus x. 2 minus x upon x minus 2x squared the whole dx. See what you did now? Now this can be integrated very easily. What about this? You see the power of this is less than this. So for this you can use partial fraction method. So next step is here integral of 1 plus this half is already there outside. Now this is 2 minus x as it is upon, I'll take x common. So 2 minus x. Now this is a product of two linear factors. So for this we'll use partial fraction method. 1 by 2 as it is. What is the integral of 1? That is x. Here partial fraction method. A upon x plus b upon x minus 2. Now you can use partial fraction method. You must have noticed because here power of this expression is strictly less than the power of this expression. That's why. Okay. Fine. Now compare the numerators here. If I compare the numerator, what is numerator there? 2 minus x equals to a into, oh, what I did. I'm sorry, here if I take x common, this is 1 minus x. This is my mistake. So here this should be a upon x and here 1 minus x. I'm sorry, this vector. Now do the cross multiplication. So, sorry, still there is something wrong here. I'm sorry, it should be here, if I take x common, here it should be x common then 1 minus 2x. I'm sorry, this is my mistake. So here this should be 1 minus 2x. A upon one factor, b upon the other factor. Now do the cross multiplication. So numerator is 2 minus x. Here a into 1 minus 2x plus b into x. Now we find a and b. So first I'll choose x equals to 0 here. So this becomes 0. And I'll put here, if I take 0, this is 2. Here a into 0, so this is 1 and 0. So it implies you will get a equals to 2. Okay. Next I'll choose x equals to half, because if I take half this will be 0. So 1 by 2 here. So I'll put 1 by 2 here. So 2 minus 1 by 2. 2 minus 1 by 2. So it would be 3 by 2. If you put 1 by 2, this is 0. B into here 1 by 2. So you are getting 3 will goes away. B equals to 3. So now I'll place these values of A and B here. So finally we are getting half into x as it is, 1 by 2 as it is there in the integral. Your A, what is A? 2. A is 2. So 2 upon x. What is B? 3 upon 1 minus 2x. The whole dx. Okay, so this is equals to half into x plus 1 by 2. 1 by 2 will goes away. So this is just 1 after opening the bracket. So here this is log of mod of x plus 3 by 2 into this is like x log of mod of 1 minus 2x upon the coefficient of x, which is minus 2 plus c. So 1 by 2x plus log of mod of x, your minus 3 by 4 log of mod of 1 minus 2x plus c. This is the required integral. So when we have such polynomial function or rational function where degree are equal or more, then you need to reduce first like this, and then you need to use the partial fraction method. Remember, directly partial fraction method in such questions is not advisable. Question number 7 here. X upon x square plus 1. You can see that this is quadratic and this is linear. So we'll use partial fraction method. For quadratic you need to write linear here. So ax plus b upon x square plus 1. This is linear, so we write constant c upon x minus 1. This is good example, remember. What we did here, for quadratic I wrote linear there. So what is the standard form of a linear function? Ax plus b. This is linear, so I wrote constant there. Now how many unknowns are there? There are 3 unknowns, so we find them. How do we do this? Same procedure, compare the numerators. So what is numerator there? X. What is numerator here? Ax plus b into x minus 1, cross multiplication, plus c into x square plus 1. What I did, I have just compared the numerators. This expression into x minus 1 plus c into this. Now we take the values of x to find a, b and c. There are 3 unknowns, remember here. So first, if I take x equals to 1, this becomes 0, remember. So let's put x equals to 1. So on the left hand side there is 1. If I put 1, this becomes 0. Plus c into 1 square. So this is 1 square plus 1. So you will get the c. What is c? That is 1 by 2, half. Okay. Now there is no value of x for which this becomes 0. So you can take any value. Normally you should take smaller values. 1 already taken. So I can take 0 now. Any value. You can take 10, 20, 100. Final a, b and c remain same. Remember, I am taking smaller value 0. I'll put there 0 here. If I put 0, this is just b. If I put 0 here, this is minus 1. If I put 0 here, this is c into 1. I repeat, 0, a into 0, this is just b, here 0, so minus 1, 0 and this is c. So you got now one equation. You take b on the other side, b equals to c. But c is half, therefore b is also half. Fine. Okay. Now next here, I'll take minus 1 because 1 already taken. If x is minus 1 here. So left hand side is minus 1 here. What about right hand side? If I go to right hand side, this is minus a plus b. Here this is minus 1 minus 2. What about this? This is c into minus 1 square plus 1, but it is 2. Now you know c, you know b, therefore we'll get the a. So minus 1 equals to, I'll just open the bracket. So this is 2a minus 2b. Now c is half, so this is just 1. So minus 1 equals to 2a minus, what about this b? B is also half. So this is 2 will goes away, plus 1. So this is 0. So this will get cancelled. So a is minus 1 by 2. So you got all the three values. And now I'm putting these values here. So this integral would be, what is a? Minus 1 by 2x. What is b? 1 by 2. Upon this quadratic, that is x square plus 1. Plus, what is c? That is also half, upon x minus 1. Now this can be integrated very easily because this is just 1 upon linear. So log of mode of denominator expression, log of mode of x. What about this? Here at least I can take minus 1 by 2 outside. So this is x, this is minus 1 upon x square plus 1 plus 1 upon 2, 1 upon x minus 1. Now this is linear upon quadratic, so you need to set the derivative. What's the derivative of this one? 2x. So multiply and dividing by 2 there. Now this is linear upon quadratic, remember. So I need 2x here. So by 4, 2x minus 2 upon x square plus 1. Why I did this? You must understand. This is as it is right now because we can do the integral of this very easily at the end. Remember, we are doing nothing with this portion. Why I have multiplied and dividing by 2? Because this is quadratic. This is linear. Every linear upon quadratic can be solved by what? Setting the derivative. What's the derivative of this one? 2x. I need 2x. So multiplying and dividing by 2. Now split into two integrals. So almost you are through here. You see, I'm splitting into two integrals at this place. So minus 1 by 4. This is 2x upon x square plus 1. This is plus 2 and by 4 already there upon 1 plus x square plus this last term as it is. Let me copy that as it is right now. 1 upon x minus 1 whole dx. Now all are the standard functions. Remember, minus 1 upon 4 as it is. This is f dash, this is f. So log of mode of denominator expression. Here this is 1 upon 2. Can you tell me integral of 1 upon 1 plus x square? It is nothing but what? Yes, tan inverse x. Plus here half as it is. What about this? Log of mode of x minus 1 plus c. Final integral. Eighth question. X upon x minus 1 the whole square upon x plus 2. You see, this is partial fraction method with repeated factor. So how we'll do? As I explained there earlier, a upon x minus 1 plus b upon x minus 1 the whole squared. Just go back to theory. Plus one more constant is here upon x plus 2. Fine. As I explained, this is partial fraction method with repeated factors. So a upon 1 factor, again repeated factors, so squared, and the last factor. Now we compare the numerators. So what is numerator there? X. Here, remember, LCM will be this much only. LCM should be same. What is denominator expression here? X minus 1 the whole square into x plus 2. The same expression should be there here. So with a here whole square, so 1x minus 1 factor into x plus 2 plus b into x minus 1 whole square is already there, so here x plus 2 plus c into x minus 1 the whole square. Be careful when you have a repeated factor while taking LCM. A into x minus 1 one factor and x plus 2, remember. B into x plus 2 and c into x minus 1 the whole square. This is LCM here. Just check. The LCM should be the same. We are just going to compare the numerator. This should be clear to you, remember. Okay, now what we do? We select the values of x as we did. First we take x equals to 1 and I'll place here. If I put 1 here, this is 1, this is 0. If I put here 1, this is 3 and this is also 0. So b is 1 upon 3. Here 0, 0 and 1, so 3. Okay. Next, I'll take one more value, 2. Sorry, here x plus 2. So we need to take minus 2. So I'll put here minus 2. So this is 0. If I put minus 2, this is also 0. Here c into minus 2 minus 1 whole square. So it is 9. So c will be minus 2 by 9. Minus 2 by 9. And here one more you need to take because there are 3 unknowns. X equals 2. You cannot take 1 because already taken. So you can take 0 now. That's the easiest way. I'll take 0. So here 0. If I put 0 here, this is minus 1, this is 2. So minus 2. 0, 0. So minus 1, minus 2. Here 0. So 2. And here 0, minus 1 whole square. So this is just c. Fine. Now you know here b and c. So we get a from this. So I'll take 2a over here. What is b? That is 1 by 3. So this is 2 by 3. What is c? Minus 2 by 9. So if I simplify this here, 9 would build the LCM. So 6 minus 2, which is 4 by 9. 1, 2 will get cancelled. So a is here 2 by 9. Okay. So now you got a, b and c and we place here, remember. So this procedure is called partial fraction method. So be careful while doing this calculation. There should not be any mistake, remember. So above integral would be a. What is a? 2 by 9 upon x minus 1. What is b? 1 upon 3 upon x minus 1 the whole square. What is c? That is minus 2 by 9 upon x plus 2. So this is the simplification of the function. So far we have not done integration. Now we are integrating, remember. What about this? 1, 2 by 9 outside. This is log of mod of x minus 1. Linear function. 1 upon 3 outside. This is like x. So this looks like x raised to minus 2, remember. If I take into the numerator. What is integral of x raised to minus 2? Raise the power by 1. So x minus 1 minus 2 plus 1 upon minus 2 plus 1. Not log of mod of, remember, because you square. Minus 2 by 9 being constant as it is. Log of mod of x plus 2 plus c. So this is equals to 2 by 9 log of mod of x minus 1. This is minus 1. So minus 1 upon 3. This will go down because the here power is minus 1. Minus 2 by 9 into log of mod of x plus 2 plus c. This is the required integral. Yes, here one more step can be done if you want. Take 2 by 9 common from this 2. So if I take 2 by 9 common, log x minus log y. So get log of a by b, x minus 1 upon x plus 2. Log x minus log y 1 upon 3 as it is into 1 upon x minus 1 plus c.